it is like the last three that we've been doing, it's kind of like there's these vague parts to it or whatever. Even when we were doing the, you know, all of those equations and we were doing regression and stuff like that, there's kind of some things that were maybe a little bit obscure. There's nothing more concrete than this unit right here. Okay? You know your steps, you practice, you will get 100% on this exam. This is probably the best test to be able to guarantee you have 100 on before you walk away. Okay? There won't be any, geez, I'm kind of mixed up with this one. Is it a perm? Is it a com? Does order matter? You know, oh, it's and, is it or? Am I, you know, none of that stuff. Okay? So it's a good unit to end with, but it is one of those units too that if you don't know a couple little things, if you haven't practiced it, you'd get killed on the other side, right? So if you put in the work on this, you're going to be very happy with the outcome. And I'm going to show you ways to always check it on your calculator, right? So it's a good unit. Yeah, we're starting with the workbook. Now, all of this stuff, I'm going to, number one, I'm going to leave you with. So there's homework in here that I'm giving you, but I'm just doing some of these kind of review. But it's those little things that you forget that we just want to kind of go through. So number 2, it says evaluate each product or quotient. Okay? So when you multiply, that's product. When you divide, that's quotient. And nothing is sweeter than multiplication because you just multiply across and you get your answer. Okay? Now, we should always reduce. And reducing, some students just struggle with it at all times. Like you got to find a number that goes into both. And 15 and 40, we can both divide those by 5. So if you divide by 5 and divide by 5, that would give you 3/8. Okay? Now again, you guys know how to use your calculator for that, right? All you do is go 15 divided by 40, hit your math, enter, enter, and it'll reduce it for you. Okay? And to even back this truck up, I mean, if you wanted to right? When you multiply, put each fraction in brackets, 3/10 times 5/4, and your calculator will give it to you as a decimal, and then you can hit math, enter, enter, and you'd get 3/8. Okay? But just the gist of it is when you multiply the numerators, get the answer. Multiply the denominators, get the answer. Now, there's also little tricks you can do, because look at 3/5 or 3/10, and so you see these? They are, if one's in the, because this is the same thing as this, 3 times 5 over 10 times 4. So you can see I have numbers in the top and the bottom. You can actually take these two and divide each by 5, so that would be 1 and that would be 2, and then you could just multiply 3 times 1 is 3, 2 times 4 is 8. Okay, so you can reduce even before you multiply. And sometimes that helps a lot because then you're not into such big numbers. Okay, C, when you have division, division is the same thing as multiplication by the reciprocal. Okay? So two things must happen. You must change division to multiplication, and you must flip it. Some people want to flip the first one. When do you flip the first one? Never. Okay? It's always flip the second one. And then you just, now, how about we could do the little trick there? See, I got a 7 and 2. I could divide each by 7, right? So that would be 1 and 3. I could divide both these by 2. That would be 1 and 2. So then you got 1 times 1 is 1. 3 times 2 is 6. Okay? You look at something like D. D messes with people. They're like, okay? Well, this is what you should do. This helps students a lot. Go 4/3. This means divided by 5/12, right? Everybody see that I just took the question and rewrote it in a different form. And then go to this. That'd be 4/3 times 12/5. And then, what can you do? You can divide each of these by 3. That'd be 4 and 1. 4 times 4 is 16. 1 times 5 is 5. So take it and write it out like this. Don't try to do... Some students like to go from here to here, and they always screw it up. Okay? Go from here to here, and then do that step. Okay, number 3. Everybody's favorite. Sum and difference. Okay, sum is always multiplication. Difference is... Now, these are the unfriendly ones, right? You gotta have a common denominator before you can add. Well, you look at A. A's all good, right? So it's 2 plus 6 is 8 all over 7. Okay. When do you add denominators? Never. Never add denominators. Denominators at the bottom, the basement, right? Okay. How about C? Now, C is 4/5 minus 3/10. Now, we need to have a common denominator. So what I always do is underneath, I rewrite the fractions over common denominator. Both 5 and 10 go into 10. Now, this one is staying as 3/10. So all I'm doing is converting this fraction so it's the same. So what I have to multiply 5 to get 10, I have to multiply by 2. Do the same thing to the top. 4 times 8 is 2. And then 8 minus 3 is 5. Over 10 is 1/2. Okay, so we're just kind of going through all the rules. I never take for granted that students come in remembering all this stuff, because math's like a language. If you don't use it, you forget it. Okay, solve each quadratic equation. Okay, well, solving is trying to figure out what would make this equal 0. Well, the nicest thing to do is try and factor it. Now, we've got x squared plus 4x. What do both of them have in common? You take an x. So if we took out an, oops, why did I write a 4? If you take out an x, that would be x plus 4 equals 0. Now, what would make this equal 0? Okay, negative 4 is that one. What's the first one that would make it equal 0? So 0, because 0 times, I don't care what's coming after, it's going to equal 0, and negative 4. Okay, now, how do you prove that on a calculator? Well, you go like this. Go into y, and go x squared plus 4x. Now, where the graph goes through the x-axis is your answers. See? Negative 4 and 0. Okay? Now, the way you do it though, because y1 is the left side, y2 make equal 0, hit graph. You won't see it, but it just drew it. And then you go second, trace, 5. Enter, enter, enter. It'll give that one. Second, trace 5. Get the spider over there. Enter, enter, enter. Okay. So you can always solve those on your calculator. Okay. Now, B. Bet you this has been a while. 4x squared minus 9. Anyone recognize what that is? I'd be impressed if someone could tell me. Okay, what do you notice about 4x squared? What kind of thing is it? Or 9. They're both perfect squares. And there's a minus sign. It's called the difference of squares. Why? Because it's got a difference in between and they're both perfect squares. So all you ever have to do is go like this. You take the square root of 4x squared, which is 2x. You put it there and there. Now, because it's difference of squares, this will always be a minus and this will be a plus. And I'm going to show you why in a second. Again, in case you forgot all this. And then square root of 9 is 3. Okay, so what number goes in there that would make that equal 0? Okay, so a trick I always do is I put this here, and then I do the opposite sign. So the answer is actually positive 3 over 2. See what happens if I go 2 times 3 over 2 minus 3? That would give me 3 minus 3, which is 0. Okay? And this would be negative 2 over 3. Okay? Now, x squared plus 9 equals 6x. Now we've got to make this equal 0. See how a and b were equal 0? We're going to make that equal 0. So that would be x squared minus 6x plus 9 equals 0. Now, this is called a quadratic whenever you have x squared something x minus 9. And that's when you come up with two things that add to negative 6. And when you multiply them equals positive 9. Negative 3 and negative 3. So that would be x minus 3, x minus 3. So what does x equal? What makes this equal 0? 3. Is it all coming back to you? Okay, so I'm just going to do this one with you. Okay, whenever you have a ratio equaling a ratio, bring that up there, bring that up there. That's all you have to do. So 12 times 5, 60. 60x, right? Equals 3 times 7, 21. Okay, now what do I need to do? Divide by 60 on both sides, because I always want to solve for 1x. Equals 21 over 60. Now 3 goes into both of those. 7 over 20. Okay. So that's all we're going to do. Now we want to move to 4.1. So what we're dealing with for this whole unit is rational expressions. Now, this is not a rational number. Okay, a rational number is anything that can be written in the form a over b. A rational expression is something that would have an x or a variable in the bottom, because that changes everything. When you have an x in the bottom, you got to be careful of non-permissibles and all those things, right? So let's just talk about it. A rational number is a ratio of two integers. Okay, for example, negative 2/5. But 5x plus 2 over x minus 3, x cannot equal 3, is a rational number. Okay, so what else? Yeah, 3 over 2x, 5x over 6x squared minus 3. Okay, those are all rational numbers, or rational expressions. Okay, so we're going to use a lot of strategies throughout, but with these, we're going to always learn the calculator tricks with them, right? Because we all make small little mistakes, okay? Just the way things go some days. And when you put it in your calculator, you're like, what? That's not what I'm getting, right? It forces you to go back and find out where 1 plus 1 equaled 3, or where you forgot to subtract something, or I was always good for forgetting to put the negative down when I rewrote the next step, or all those little things. No. Okay. Now, important things to remember. A rational number is undefined when the denominator is equal to 0. Okay? That's going to be gigantic, huge, 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 right? So when it's like 5 over 3x, we will always say x cannot equal 0. Why? Because that would be 5 over 3 times 0, which is 5 over 0. Even your calculator, try it. If you go 5 divided by 0, okay? Can't divide by 0. It's like yelling at you. Okay? Nice and clear. You can't divide by 0. Okay? So, never can you divide by 0. And it's a whole philosophical thing, right? If you had 5 pizzas and you divided it by 0 people, how much would they get? Nothing? Okay? There's no people. Right? So, some people would say, well, they'd get 5 pizzas. Who would get it? Nobody? Nobody would get 5 pizzas. Okay, so if nobody got 5 pizzas, how much did they get? And they're back to like 5 again. Well, okay, you're missing the point here. You know the one philosophical thing I never got, you know, the old, if a tree falls in the forest and no one there to hear it, would it make a sound? I'm like, yeah. Like, yeah, exactly. Put a few, like, I don't know, scientific instruments out there. If the little needle moves, right? And then, but it's weird how people actually make it philosophical. They're like, oh, but sound is like what people hear. And I go, no, not true. If there was a squirrel, he would have heard it, you know? I guarantee it makes a sound, right? I think it's just people with like too much time in their hands, or they've been doing something they shouldn't be doing. They're sitting around going, hey, let's talk about this useless thing. Okay? What's that? Yes. You want you want to hear a true story? This is. Yeah, they did find my car. Mm-hmm. Oh, they didn't catch him. Okay, so now. Anyway, back to the you can't divide by 0. That's how it all started. All non-permissible values of a rational expression must be stated as restrictions. Okay, so that's always going to be a habit. So, like if you had this question, 5 over x plus 3. Now, could x be 0 there? Yes, x could be 0. That'd be 5 over 3, wouldn't? 5 over 3 is not a lot. What do you got against that? What would be bad there? Right. So you always have to state what is bad in every single question. Okay? So if it's not defined, when is it not defined? How about this? 5 over x squared plus 4. What would be bad there? Negative 2 squared is 4. 4 plus 4 is 16. See, there's no non-permissibles on that. How's that for philosophical right there? There is no non-permissibles. They're all permissible. Now, and then substitution can be used to determine if two rational expressions are not equivalent, but it cannot be used to determine if two rational expressions are equivalent, and we'll get into that later. Now, the first thing we're going to talk about is equivalent, okay? Because if you had a pizza, right, and you divide it up into here, so that's, and so how much is that? The shaded would be 2/4, right? Now if you came along and just went like this, okay, would you get more pizza? No, okay? So in that case, we would say that 2/4 would equal, say, 4/8, right? It's the same thing. Those are called equivalent. And as long as they both change by the same, they're equivalent. Like 2/4 isn't equal to 2/6 or isn't to 4/12, right? And you can always tell if they're equivalent because, oh yeah, times 2 times 2. As long as you're multiplying by the same number, it makes it equivalent. So 8/12, which the question asks, what would something equivalent to it? Now you don't always have to go up, you can go down. Okay, what would be equivalent to it if we went lower? Okay, well what can I divide each by? Because you can divide each by 4 or by 2, so that would be 2/3, right? Someone says divide by 2. That'd be 4/6. Okay, you can also go 8/12 and multiply by 2, which would be 16/24. Okay, those are all equivalent. So as long as I do the same thing to the top as the bottom, it actually is the same amount. It doesn't change it. Okay? Now, we're going to take this just a bit higher level. Let's go and write an equivalent, or two equivalents of 4x squared plus 8x all over 4x. Now, one easy way, probably the easiest, is to always multiply by 2. Okay? So if I took this and multiplied by 2 and that multiplied by 2, just make sure that you're hitting both of these, not just one of them. So that would be 8x squared plus 16x all over 8x. And then you would have to say that x cannot equal 0. Okay, another thing you could do is you could factor the top. Now what can you take out of 4x squared and 8x? What can you pull up front? What can you divide out of both of those? 4x. 4x would be the best, right? 4x is the most you could take out. So 4x, and this would be x plus 2. And what's on the bottom? 4x. And that crosses out. That would equal x plus 2. Now what's weird about these though? The answer is x plus 2, but you still must say x cannot equal 0. Why do I have to say x cannot equal 0? There's no x down here. See, there was once an x. And once it's not allowed, it's always not allowed in the entire question. Things don't magically disappear and now a restriction is allowed. Okay? And that's a big, big thing to always remember. Look at any time in the question if, oh yeah, x cannot equal 0 there. Don't go, oh, but no, I canceled it out, so it's all good now. No. It was once bad in that question. It'll always be bad in that question. Okay? That's crucial. I don't know if they're going to be trying to catch you on that much, but just so you know, If it is ever bad, it's always bad. Okay? So now we're going to talk about, again, non-permissible values. Okay? AKA restrictions. What numbers are not allowed to play? Now, A, that one, most people can do that one visually. But what would be the answer there? X cannot equal what? 4, right? Because 4 minus 4 is 0. Now here's how you can do it algebraically. Write out this statement. X minus 4 cannot equal 0. I'm saying the bottom cannot equal 0. And then you just do some algebra. Add 4. X cannot equal 4. Okay? So you can always do algebra on the bottom. You can just always say this cannot equal 0. Okay? Same with this one. Negative 3x minus 15 cannot equal 0. That's the truth. The denominator can never equal 0. And for those students that they're not good at it, they just can't look at it and do these, well, do the algebra on it. So this, I would add 15 to both sides. Negative 3x cannot equal 15. See, usually we're always putting equals, equals, equals. Now we're just going to keep a not equals there. And then I'm going to divide by negative 3. X cannot equal negative 5. Okay? So remember, C, this bottom cannot equal 0. Now don't ever get that mixed up with the top. I never care if the top is 0. If I had nothing and divided it by 5 people, how much would they get? I can give you an answer for that. That is true. Okay? If you had nothing divided into 5 people, they're getting nothing. Okay? So some students later want to try to give me that x can't equal 0 on A. And I'm going, what do you mean? 0 minus 4 is negative 4. They're like, no, but the top would equal 0. And I'm going, the top can equal 0 all day long. Doesn't matter. Okay? I just care about the denominator. And it's like when students start these, they get it. And then after a while, it's almost like they start getting almost too particular, and they want to make sure nothing can equal 0. Only care about the bottom. Okay? Just the bottom always. So this one here, I got x squared minus 5x cannot equal 0. Now the best trick is to always try and factor something out. What can I take out of both of these? An x, leaving me with x minus 5. And then the answers just pop out. Okay, that should be not equal 0. So what would be bad here? In the front? 0, because 0 times anything is 0. And what would be bad here? 5. So x cannot equal 0 or 5. Okay, just going to deal with this one here. These are always everybody's favorites, words problems with fractions. Now, this is actually a question that's on the always in the grade 9 achievement test. And it's like, it's this kind of question, okay? It's always, well, one hose can fill it in this amount of time. A larger hose could fill it in this amount of time. How much could 2 hoses do it together? Okay? Or, you know, John can mow his lawn in 1 hour. Okay? Jane can mow hers in same lawn in hour and a half. How much would it take together? Okay? Or here's one that's very common, that one hose can fill in 3 hours and another hose could fill in 5 hours. Okay? So it could fill a tank. How fast could they do it together? And you know what the most common answer is? 4 hours. But if you really think about it, you could do it alone in 3 hours. Right? And you know what students do? They go 3 plus 5 and divide it into 2 and get 4. Okay? Yeah, it's the average of the 2 times, but it's not if they did it together, because this hose by itself can do it in 3 hours. This hose can do it by itself in 5. Therefore, it's got to be less than 3, right? If both of them are together. It should be, but 4 is the most commonly picked answer. Okay? So this is the way you do it. Okay, you can just watch this because we'll do it differently. But if it's one hose can do it in 3 hours, plus one hose can do it in 5 hours, we want to know if both of them are together as one hose would take how long. Okay, and then there's different ways you can do it, but we can do it with a common denominator. Let's do them to add these together. We would have to put this over 15, right? And then what do I have to do here? I have to multiply by 5. So I'd multiply this by 5. So that'd be 5/15. And this will be 3/15. So it's 8/15 equals 1 over x. Okay, so how do you solve for x? Well, we want x up here by itself. Bring the 8 down here. Those two can trade, and the 15 here. So it'll be x equals 15 over 8. Now, 15 over 8, you might be like, what? But you can convert that to, so you just go 15 divided by 8. So together they would do it in 1.875 hours. Little less. Okay? Now, I've always, when I used to teach grade 9 math, I would teach the achievement exam as a unit, just like I'm going to do with you guys in the diploma. So the way I would do it is I had 5 achievement exams, older ones, and with ones I made, and we would take 11 days, and this is how I would do it, is I would give achievement exam. Then the next day they'd get it back, and they'd have, as their own time, work with a partner, the whole thing, go through every one of them. And I did that 5 times with 5 different exams, 10 days, and then I had a final exam, and the final exam was questions from those 10, or from those 5. Okay, but all spread out, right? So then they would do that. So we'd have the 10 days, and you could see the accountability was there because the kids wanted to make sure that everyone they didn't get, because that's the one that's going to end up on that test, right? And then they'd write that test, they'd get their unit, and the students could just destroy the achievement exam. Just destroy it, because every one of those questions were on the new achievement exam, right? So they looked good, I looked good, right? But we did it as a unit, right? We just worked on the, and that's what I'm going to do with you guys in the diploma, same exact thing, right? So then when you get to the only bad thing, the only thing that's different is the achievement exam would be 3-4 days after I finished with them, where you guys it's almost 2 weeks after, right? So that's the only disadvantage that you guys have going in, because if you could write it the next day after we're done the last day of classes, you'd probably do the best. So you're going to have to your job to maintain that, right? But so that's what this one always reminds me of, right? Because they always ask this question, right? And then when I get my analysis back all the time, like I'll know what every question you guys do and how you did on every one, and which ones I want to work on more next year and stuff like that, right? And so I could see that they're all getting that one or whatever. But all of these exams are just very calculated, like what they're going to ask on every one of them, right? So that's why that week and a half that we do of just diploma prep will have you 100% ready for that diploma. And it's just kind of stuff like this, like once you've seen it once, you're like, oh okay, I see how to get that now, right? Instead of struggling with it for half an hour on the diploma. So this one is very much the same kind of thinking, but it's like one hose can fill the pool in Y hours, or T is probably better. So that would be 1 over T. We always put time on the bottom, because it says larger hose. Now, if you had another hose that can fill the pool 20 millimeters faster, okay, you'd have 1 over, instead of time, well, you know what? Let's change this to 20 minutes faster, because this is just a bad question, okay? But if you could do it 20 minutes faster, what would be the denominator on this one? T plus 20, right? Yes. Yes, T minus 20 time. Yes, T minus 20. Okay? And if you had to do a non-permissible, T cannot equal, what's bad down there? T cannot equal 20. Okay? So that's kind of all we're getting. Obviously, not even getting this in depth, right? But, okay. So page 88, that was 4.0. We're doing 1, 2, B and D, 3, B and D, 5, A and B, and 4.1, page 91 to 93. Yeah, so even this would be another way to phrase this. It would take 20 minutes less. That's why we want to. If it took 20 minutes more to fill, we would add T plus 20. Okay, so you guys should all, this is all really fast stuff. I know that it's review for a lot.